I do want to start out with some fair warnings, okay? Those who know me know these are my opinions only. A little bit different than what was said earlier, but they're still my opinions. I am biased, so I'm going to give you a perspective from the industry. You'll see that kind of littered throughout the whole talk. I reserve the right to be wrong. This is one of the best statements I've ever heard. We can have opinions, we can debate things, but always reserve the right to be wrong. So anything I say, if you disagree with, certainly can be convinced otherwise. And I'm barely over 50. I'm not going to tell you exactly what, but anyway, I don't work in a university, and therefore I'm able to give my opinion without recourse. So for what it's worth, if you don't agree with anything, just refer to items 1 through 4. So I want to start out, I maybe took a little bit different approach to this talk. I do want to delve more into some research opportunities that I think we have as an industry. I want to kind of walk through that by just giving you some context of how I looked at that. I do want to talk about what I think are some major problems that we are faced with as a swine industry and where those opportunities might be for research. And then I do want to end with a nice discussion on where I see the needs for training future students in animal breeding. So in general, I think as we all understand, the problems that we face in the swine industry are complex. And I don't, when I first put this slide together, I think I was trying to say our new problems are complex, but I don't think that's true. I mean, when we think back over the last 20 years, and I'm of course familiar with the work that was done at Clay Center and University of Nebraska on uterine capacity. That's a complex problem. So we've always had difficult challenges to deal with, but I think the key is that with the new technology that's available, certainly solving these problems is more efficient and does require a team of people that have training in multiple disciplines. This is a combined meeting with a large veterinary audience. I'm going to pick on Paul. I'm so proud of Paul for being here. He's probably one of the only vets here in the room, but we actually do need veterinarians too, and we probably need a few nutritionists to help us with these things. So, but as geneticists, for us to be successful, as I kind of think back of the things that we have to accomplish every day, for us to have an efficient transfer of superior genetics, for us to realize the genetic potential that we can create, we do have to leverage these other disciplines to get that done, and we need help doing that. And lastly, the fact that these are challenging problems and they have complex solutions, we always have to keep in mind that we can't violate the law of genetic improvement, which is I over T. And the more I go through my career, the more I realize how important it is to focus on I over T for long-term success. If you look at the companies that throughout the years have come and gone, usually the reason that they fall behind and the reason that they fail is because of the compromise that's made with I over T. And we'll talk about that a little bit later as well. So I think one of the big problems we're faced with in the industry, and as I go through these, I am going to deviate from genetics a little bit and just kind of share, I guess, some of the issues I see in the industry. And even for this audience, I know we have geneticists in here, but we have veterinarians, we have people doing research in disease, we have people that are doing research in reproductive physiology. So I think all of this can really tie together. But I think one of our big problems as an industry, frankly, is multiplication. And what I mean by that is I think it's a major roadblock to our competitiveness. And if you kind of walk through this scenario, and you could probably argue these costs, but if I was to go out and put up a 5,000 sow unit, I'm going to have about $15 million in it. I have to build wean to finish for that flow. That's another big chunk of money. I have to buy the inventory, and pretty soon I have millions and millions of dollars invested in this one flow. One health break renders that farm a commercial farm immediately. It's worthless in terms of multiplication if it cannot stay healthy. There's transport costs and risk as we raise gilts perhaps to maturity. Depending on the type of flow that there is, we have a tremendous amount of transport costs of older animals. There's risk in that transport cost, but we're moving animals all over the country and we're paying for that. And the acclimation period to the sow farm also affects the productivity. So we take a look at that. Some people have tried some different things. I think as an industry, if you look maybe back 10 years or so, the industry tried, not everybody, but a lot of people tried internal multiplication, so producing gilts on farm, flowing those through the same farm. That generally failed. It's not because it should have failed. It's because when you're working with a team of people on a farm that are very focused on commercial production, and you throw a purebred in the mix, and you put different genotypes in that same flow of pigs, keeping all of that straight and separate is really kind of what causes that to fail. So it's a challenge. I think we're seeing now, and I think we'll see this more in the coming years, is a movement toward on-site GDU, so gilt development units, where the customer of a genetic supplier will receive wean gilts, so basically you're transporting them earlier in life. There's a longer acclimation period because they're raised on the recipient sow farm. You lower your transport costs, and overall you can reduce your multiplication costs. So I think those types of things are being looked at, but I think we can do better, and here's where we get into the research side. I really think embryo transfer is an area that I hardly ever hear about in terms of research, but I think it's an area that we really need to focus on as an industry to assist us with moving genetics. Generally, I think there's a lack of research in the area. There's very limited availability of this expertise in the swine industry. There's a few groups that will offer these services, but it's generally not widely available. But I think the economic return can be huge. We can dramatically reduce health risks. If you have a multiplier, even if it breaks with disease, if we have the technology basically to clean those embryos, if you will, or wash them, we can still do a transfer of superior genetics. We can transfer directly into the commercial flow. So we're not maintaining a different type of sow on the farm, but transfer in the commercial flow, move that to an on-site GDU, and really assist health. It's going to help with international movement of genetics, and it's truly an opportunity for us to reduce genetic lag and perhaps increase genetic merit of the product that we're selling. So when I'm talking about embryo transfer, I'm really talking about researching this from A to Z and improving its efficiency. There's a lot of pig people that raise cattle. Are there any other cattle raisers in here besides myself? A show of hands, I know a few of you do. If you've ever done embryo transfer, it's a wonderful technology, and it's obviously further along in cattle. But in cattle, we deal with maybe 50 or 60% conception rates on embryo transfers. I feel like I mortgaged my first child to Transova to get embryos. There's a lot of inefficiencies. Yes, it works. Yes, we can use sex semen, but it's really not to the level we would need it for this industry to work. So if we're looking for that long-term, that 15-year vision, I think this is an area of opportunity for us as an industry. We're probably all going to get tired of listening about gene editing. It was back when I was in grad school, it was all of genetic markers and marker-assisted selection. I think this is probably the new one of those we're going to get tired of hearing about. I want to ask everyone a question. Or a couple questions. Has anyone ever seen this chart before? I know a couple of you have. So what this is, this Gartner hype cycle, is supposed to depict the application of a new technology. So when the technology first comes out, you have a technology trigger. Everyone's excited. It's going to save the world. It moves up. Lots of money, millions of dollars flow into it. You get a lot of inflated expectations, and then boom, the bottom falls out. People realize it's not everything they expected. And pretty soon, though, the industry catches up and the technology catches up, and that's that slope of enlightenment and the plateau of productivity. Just to give you an example, I would argue that when I was in graduate school, the team at Clay Center was working on the microsatellite maps, the first maps of the genome. I heard different people, not from Clay Center, but just in general, that by the end of the decade, so this is in 1993, we wouldn't have to collect any more phenotypes because we'd understand all the genetic variation. Well, I would say at that point we were way on this left side over here. Then we went through marker-assisted selection, and I think that was a great advancement in technology, but if you ask people in the industry, they'll say they got very little benefit from marker, or visible benefit from that. So we kind of went through this trough, but then we came through a slope of enlightenment, and I think if you look at genomic selection today, we're really getting up on that plateau and making a lot of value from it. Gene editing, where does everyone think we're at today? I probably biased everybody, but I think we're over here on the left, I don't know where, but it will come of age, and I think that's an important thing. So I don't want to talk about the methodologies and the patent fights and all those things, but I think the implication for research in our university system is the limitation is the target. So when you edit, you have to know what you're going to edit. You have to know the exact variant that you want to change. So research into understanding various biological pathways, meat quality, reproductive function, disease susceptibility, understanding those pathways, understanding the genes that are involved, characterizing the alleles, and knowing what to edit is a huge basis for us to build on going forward, because as this technology matures, that's where it's going to be leveraged. And I think we can prepare for this technology by continuing to emphasize those key aspects of swine production, or those key biological pathways that we need to be successful. But if you go on a step further from that, and we think about applying this in a breeding program and being prepared for that, you can come up with a multitude of ways to put this into a breeding program, and I'm just going to share one. But I think the application of gene editing has to eventually fit in flow. So what I mean by that is if we want to make a one-off edit and create this whole new population with the edit, I don't think that's sustainable. I mean, think of the number of edits any one of us can come up with. We want to change this, and next year it's that. You're not going to recreate your population. So you have to be able to fit it within your genetic improvement, your law of genetic improvement, or I/T. So I would envision a situation where we would continue doing what we're doing. We're going to phenotype selection candidates, we're going to select replacement animals, and then we're going to mate those animals. Well, what do I mean by mating? If you think in terms of gene editing, we're going to need to harvest oocytes from selected females. We're going to want to use in vitro fertilization to produce embryos. Then we're going to go through an editing step, because we want to introduce this new edit into our entire population and at the same time keep improving the population that we have. We cannot afford to produce a product that's inferior day to day just for the sake of one allele in the system. So from that editing step, we need to culture and possibly select which embryos have the edit. We need to transfer those into recipient sows, and we got to do that every week. So if we're going through a new turn, a 20-week turn of the sow farm, maybe we'll just do it on sires. Like I said, there's different variants of this, but we have to be able to do this in flow. So the key point here, though, is IVF and embryo culture. So going back to what I said about embryo transfer, you see that show up again. I think understanding more about in vitro fertilization. And again, it's not that we haven't developed these technologies, but in my mind, they're not as efficient as they need to be for us to put them into application on a grand scale, at least in the way we operate the pig business. So I think this is another opportunity for us to prepare for gene editing, and actually lends itself well to the whole idea of transfer of genetics also. So what other things can we look at? I think there's a lot of significant challenges, and I just want to share a few our view of the world in terms of the challenges that I think would fit well with more cutting-edge research in the swine industry. We need to continue to address disease susceptibility. There's been a lot of effort put into this already. Obviously, a lot of research with PRRS. We understand the genetics of PRRS fairly well. But once you get beyond PRRS, there's a lot of really challenging diseases out there. Swine influenza virus, strep infections, various enteric issues that we have to deal with. All of these have an immune system component that we need to understand better, and hopefully it would lend itself to improvement in our populations. Another area that I think is extremely important to industry is we need the continued development of analytical methods and software. This is an area that I think is a challenge for universities. It's not sexy, it doesn't bring in millions of grant dollars, but it is absolutely crucial for the success of not only the swine industry, but virtually any industry involved in animal breeding. We need faculty and students to continue to work in this area. We need to figure out how to fund them. And I would argue that over the years, the different programs that have been available for animal breeding, if you just look at the impact they've had and the dollars truly generated, that research probably has had more return on it than virtually anything else. Development of novel phenotypes, I think, is an interesting one as we look to what we need as an industry coming from more basic research. We can generate a lot of phenotypes in our breeding program. So I want to give you just an example of that. I would not advocate, if we're looking at improving pig quality, that a university, in a university research herd, for example, look at pig birth weight. At DNA, we generated over 400,000 birth weights in the last 3 years. It took $250,000 for us to even understand the maternal effect on pig birth weight and to begin implementing that in a program. You're not going to generate that at a university in a research herd. But what we do need help with is objective, and some examples here that I think are really important. As we look to the future and perhaps more loose sow housing, structure today, calling a spade, yeah, there's some scoring systems out there, but you know, when pigs are coming off test, we have a person that goes out and will select those pigs based on a visual appraisal. And there's no objective measure for measuring structure or understanding the impact of that measure on lifetime productivity. So I think there's some key areas of research there that we need to support. Another one that comes to mind, meat quality, I think is going to be incredibly important in the future as the industry integrates. We talk about these branded products, as we heard this morning, but how do we measure that in a live animal? And I guess I would put out that challenge is a very important thing that we could really use as genetic suppliers is how do we measure in the live animal some indicator, some biological trait, biochemical, a biopsy, whatever it happens to be, what can we measure in the live pig to give us a phenotype to accomplish the objective? The reason I say that is, yes, we can take pigs to the plant, they can be pedigreed, but if you look at the time it takes to do that, and it's post-selection, you can't have a dead pig reproduce very well. So we need something that we can back up in the life cycle, and I would put that challenge out as an opportunity. And another one is pig behavior. We're really not set up very well in industry to do research on behavior, whether that's sows in large groups, just pig behavior in general, and if there's an opportunity for us to leverage that information and make improvements in performance. The cattle industry has done a lot of work with identifying lethal recessives that cause lower calving rates. I would maybe argue that that's an area that we could look at in the pork industry as well. We should be gathering DNA samples from all mummified pigs and so on and try and understand if we can work on eliminating lethal recessives and help us with litter size and pig quality as well. Just some other big problems in the industry. I think pre-weaning mortality continues to be a challenge for us. I really don't have much else to say about that other than the best herds in the industry are going to be below 10%. The worst herds in the industry are going to be above 20%, 25%. So I think there is opportunity for us to understand how we can impact pre-weaning mortality. Sow mortality as an industry has been creeping up, I think, across all genetic lines as we're improving productivity. We're demanding more from a sow that has to produce a pig that goes to 300 pounds and stays lean, and expect that sow to lay down and raise 14 or 15 pigs. We need to understand all those relationships a little bit better, and I think that's a great opportunity. And lastly, sex semen, if we can get that, and we're going to hear more about that this afternoon, I see. Obviously, sex semen could have a huge impact for us, especially if we can do that in large volume without, hopefully at some point without surgery and so on to make that viable. So just maybe took the talk in a little bit different direction, but I understood that's maybe what we wanted to do today, is to issue or look at how we view the world, what types of research that we can do and prepare students to do in the universities. So I'd like to move into some thoughts on training students, and this is where I was very excited, as I mentioned earlier, because I think you'll find a lot of similarities here with what was stated, but I'm again going to give this from the standpoint of industry. And I hope for faculty and students alike, you'll find something in here that is relevant and important to you. The first one I put on here, and you'll notice it doesn't start with a technical issue or a technical training. The most important thing I think we can do for our students is their personal development. And I really want to challenge faculty members to be a mentor to your students. We need to make it a priority that we know our students personally, know who their boyfriend and girlfriend is, know what they're doing in their personal life, know what they did over the weekend, not because you want to be fake and phony and all those types of things, but you really want to get to know who that person is and what drives them. You want to know what their strengths are so you as a mentor can help guide them along their path to becoming the best that they can be. Dr. Holberg mentioned, we have some students that are better slated for academia and some students that are better slated for industry, and I think we need to help identify who those students are and really help them understand where they would best fit and where their drive should be. And I think as faculty members also, and I would say this also of myself or anyone else that has the opportunity to work with teams, is we need to know you need to know yourself well and the type of student you best produce and the type of student you can best mentor. So a good chunk of my team is here. You'll know on my team, if I have to tell you what to do every day, you're not going to be working for me very long because I'm terrible at that. We need to talk about objectives, and you got to be able to take that and run with it. I'm not the type of leader that can work with a student every step of the way and tell them everything they need to do. Other people can. That's not my strength. So as a faculty member, you really need to understand that, because you're going to be more successful with your students. So developing their soft skills, I think, is important. And I'll talk later about, leadership skills and communication skills in a little bit more detail, but those are the soft skills we need to develop in our students. But this last point I think is really important here as well, is being honest with students, and I think there's a lot to that. We need to build their confidence. We need to build confidence in our students in a public way, and we need to build it privately. We also need to be honest with them and help them understand and strengthen their weaknesses. And you don't do that, publicly. I don't think any of us probably do. But I think students, and actually faculty alike, all of us throughout our lives, need good, honest feedback. When a student gives a talk, after that talk, review that with them privately and say, here's what you could have done better. You did a great job here. But build that confidence and help them to see. Don't let a person go through their whole program and never have that personal feedback. Ability to work on a team, we hear this time and time again, and it's certainly no different in our company. We have a team of people. We're all about team at DNA Genetics, and we're probably not alone in that. If you want personal recognition and a title, I know that our company isn't the place you should work, and I'm probably saying that that is true anymore of a lot of companies in our culture. It's a team-oriented environment. We're going to be successful together, and everyone has a key role to play in that success. And when that happens, it's a really beautiful thing to watch in action. We need students with leadership skills, and I think they can obtain those through leading research teams. So a group of undergraduates working on a project, for example, those are opportunities to develop those skills, and then communication, of course, presenting, writing broadly, those different opportunities. Communication, I think, is extremely important. In this quote, we say a lot in our camp, the most valuable people in the technical realm can explain the most difficult concept to a team member at the slat level. So in pigs, we can talk about slats. You can talk about feedlots if you want to, or something like that. But at the slat level, and that person will know precisely just how important that role is. And a lot of times I think we overlook that. So if we go to different conferences and so on, highly intelligent people can use, can really understand their subject matter well, but if you can't explain it, it's a skill that's really challenging to teach, and some people can do it and some can't, but we need to help people develop that through teaching experience, industry extension, and farm experience. And I would say also the reason all that's important is because the most important people in a company and in a genetic company are not the geneticists. It's the people on the farm that have to collect the data and make the decisions every day. And if you can't teach them and you can't have them understand what they need to get done every day and how important it is, the program will not be successful. And that's why those skills are so important when you're coming into industry. I'm going to go quickly through this because we're pushing up against lunch, and I know we want a few minutes for questions, but as far as training, I think it's extremely important. I guess my bias would be to focus on a quantitative type of training, but understand how to model phenotypes, how to do trait development, and to understand the results of your work. Know how to run a genetic analysis is important. Multi-trait genetic analysis with and without genotypes. The common software in the U.S. today is really coming out of Georgia, and maybe we'll see a little more out of Bolt as time goes on. But that's the software you need to know. I haven't met too many companies that aren't using a lot of the Georgia software. Know how to apply statistics and experimental design to non-breeding data sets. So get involved with consulting in other fields. Nutrition studies, growth curve analysis, working with messy field data. Your skills in quantitative or statistics are going to come into play beyond just animal breeding problems. And also get some exposure to novel methodologies for data analysis, machine learning, those types of things. But I think that type of background lends itself well to a general background that can be applied to a lot of industry problems. I do want to spend just a minute on this slide, and then I'll wrap up quickly after that. One of my biggest concerns on training students is on this slide, is we need students that still know how to run a breeding program. If we look at, and people have called it different things, but the I/T equation still to this day drives everything we do. And we need students and faculty that understand the importance of knowing this equation inside and out, everything that impacts it, and how it functions day to day in a breeding program. Down on the bottom, you'll see just kind of a generic equation for a selection index, and I would argue the A's, or the economic values, are just as important to teach as the EBVs. So what I mean by that is we need to be able to understand the impact of these traits in a true production system and how to derive those economic values. They're not just something you grab out of the air. They're a very key aspect of our success. And if I was a faculty member and probably going to give some terrible ideas here, but I would give like a 6-month long final question for a PhD student. I'd give them a data set with about 10 traits and data on 100,000 animals for each. And I'd say, go build a breeding program from this. I wouldn't give them the economic value. I wouldn't analyze the data. I would just say, go build this. And force them to go out and really understand which traits are important here. Talk to industry, figure out what those values are. And they don't have to be right, but the point is that would give someone a tremendous amount of experience and really understand how it all comes together. Programming and computing, SQL and R, I think knowing a little bit about those languages is important for a student. And lastly, this is my last slide. Maybe just a few comments directly to students. I know we have a lot here in the audience, but learn everything you can. A PhD program on average takes about 5 years. The university is paying for your classes. Take every class that you can. I mean, whether it's in statistics or outside of your area, just take everything that you possibly can. Seek opportunities to lead, whether it's a group of undergraduates, perhaps mentoring a new student, but seek out those opportunities and challenge yourself in your own personal development. Teach while you're there. Seek opportunities to teach an undergraduate class. Teach a group of producers something new that puts you in a position where you have to explain and answer questions, and those skills will be highly valuable to you going forward. I'd encourage you to do something collaborative with industry, whether it's an internship or just a collaborative project, but getting that exposure, being out on farms perhaps, working with that data is going to be important. And lastly, and this is one that I think is important, is don't be afraid to tackle big problems. That's where the most return and value is. Don't be afraid to dig into those big problems, and I really love that picture in the lower right. But those are the types of things that will set you up for success long term.